Hello, scholars. Well, some of the most famous quadratic problems that we solve are dealing with projectiles and gravity. Uh, the way that a object travels to the Earth, if you've learned in your science classes, is the acceleration due to gravity is a per second squared, which means that it has a quadratic form to it. So we're going to take a look at a few of the projectile motion problems that are in your notes, and we're also going to use Desmos to also model it, so a couple of different ways. So this first problem is about a soccer ball kicked from the ground with an upward velocity of 90 feet per second. The equation that is given gives the height of the ball after how many seconds that it travels. And so we're asked first to find the maximum height of the ball. Now, really, if we're thinking about the maximum height of the ball, think of this as we're really thinking about the vertex of the parabola. So the maximum height of any parabola, and notice that this parabola is opening down, is going to be its maximum. So we're going to just use the same idea that we did before and find the values of both the time, which is the x value, and h, which is the y value. And so the first thing we're going to do is negative b over 2a to find the axis of symmetry, or the x-coordinate of the vertex. In context here, though, this is the time at which the highest point is going to occur, which is approximately 2.81 seconds. So that gives us the height of the ball, or the time. And then to find the height, we're just going to plug that in to the equation and go ahead and just round to 2 decimal places is fine. And so it's going to be approximately 126.5 feet. Okay? The second type of question we can answer with a projectile equation like this, or motion equation, is how long it takes for the ball to reach the ground again. And if you think about that, what we're really asking is what is the height, what is the time when h is equal to 0? So when the height is 0, when it hits the ground, what is that time? So if you think about that, what we're really doing is we're taking this projectile equation and we want to know when is it equal to 0. So one thing we might do is try to factor it. If you see, we can factor this into the greatest common factor is negative 2t, and we factor that out, and then really just solve both of these equations. And so it's not surprising that one of the solutions is going to be the time is 0, because initially the ball is kicked and the time starts. So that's when the time is 0. The other time that we're going to have is we just solve that equation, 8t minus 45. So 45 divided by 8, when you solve that, will give you approximately 5.625, which tells us that that's the next time when it's going to be 0. So we're not concerned about the initial time, because we want to know when does it reach the ground again, and so clearly that's going to be 5.625 seconds. So what we want to do next is I want to take a look at this on Desmos. So here we're going to use Desmos.com. This would be another way that you could investigate projectile motion problems. It might be effective in your Delta Math activities as well. But notice here that we're going to use that same soccer, the equation for the soccer ball as it travels, except that notice that I'm not using h and t. I'm going to use y and x instead. And so when we graph this, notice that it just we can't really see where the vertex is, so it might be good to adjust to the y-axis. We know that the height is going to be 126 or something like that, so you can use that with the little wrench and maybe change the y-axis and have it go up to, oh, I don't know, 150 or something like that. That might be okay with that. So clearly now you can see, and if you need to move things around a little bit, you can just click on the mouse. But go ahead and what you could do is notice that we can find the vertex just by clicking on that point. It will give you that maximum, and notice that it's confirmed by the algebraic method we used, is that at 2.81 seconds the soccer ball's height is 126.56 feet. The other thing you could notice is down here where the roots are, or the x-intercepts. Notice that these are the two locations where the heights are 0. So we could also answer that question if we needed to, about when it meets, or when it hits the ground, because we're going to say that a height of 0 is the ground. So this is another method, a graphing method, that confirms our algebraic method. Okay, so the second one, it would not be fall if we didn't talk about Apple launching, and this one happens to be launched from a rather high platform, an 80-foot platform, and we're given the equation here again in terms of the Apple's height and time. So you can see again, this is going to be a quadratic or a parabola that is opening down. So the first thing we want to find is the maximum height of the apple, and so again we're going to find the vertex. And so if we take, we'll do this algebraically first. If we take negative b over 2a, we find that the time that the vertex occurs is at 2 seconds. And so we'll plug that 2 into the equation and go ahead and evaluate that, and find that the height of the apple at the maximum height is 144 feet. And then we want to know how many seconds it will take for the apple to reach the ground. So again, we're interested in when is the height equal to 0, when is this equation equal to 0, and so we certainly can begin to try to factor that. And if we do factor it, notice that we have we can actually factor out a 16, and then notice that this is factorable. So if we factor out the negative 16, and I said that it's usually good to factor that out first, notice that we can then factor the remaining trinomial into two terms. And so if we factor this, notice that we get, well, obviously negative 16 is not equal to 0, but 0 positive 5 will make the quadratic 0, and also negative 1. And so clearly we're interested in the positive value. We're not going to go back in time to negative 1 second. That's not possible in reality. So then that's going to be the time that we're interested in. So if we jump back on Desmos.com and take a look at the graphing that we've done here, again, this is the original equation. And so a couple of things we want to point out. Notice that if we look at a couple of the characteristics, notice that y-intercept was the 0, 80. Notice that connects with the 80-foot platform at which the apple was launched. And then if we take a look at the vertex, that is 2 seconds, and it is at 144 feet, which it's a maximum. We found that algebraically. And then notice that the x-intercept is going to be 50, which means that at 5 seconds it reaches the ground. Now, if you want to know where that negative 1 came from, of course that in a mathematical world of parabolas where you can go back in time, this would be the answer to that. So you can certainly use a graphic approach or algebraic approach to these problems, but you should be able to find both of those quite interesting.